Hi everyone, welcome to another lesson on bite-sized math made easy. Today we're going to learn about equivalent fractions. So what are equivalent fractions? Well, equivalent fractions are fractions that have the same value. Okay, so they may look different. The numerator and the denominator, the number above and below of the fraction, will have different values. Okay, so for example, 1 over 2 and 2 over 4 are equivalent fractions. They have the same value. Okay, but you can see that the numerator value for the first fraction and the second fraction are different. Same with the denominator. This one has got 2 and this one the value is 4. Okay. All right. So let's take a closer look at equivalent fractions. Here we're going to show that 1 over 4 is equivalent to 4 over 16. Okay, so we're going to take two squares of the same size to demonstrate this. Okay. All right. So for the first square on the left, okay, so if we have divided it to 4 equal spaces. Okay, so this one divided to 4 equal pieces, that makes the denominator, and we say is 1 over 4, and this one is divided to 16 equal spaces and 4 over 16. So for the one on the left, since it's 1 over 4, we're going to shade just one of the squares, and the square on the right, since the numerator is 4, we're going to shade 4 of them. 1, 2, 3, and 4. Okay, so for the first square we have shaded 1 over 4, and for the second one we have shaded 4 over 16. But if you look at both the squares, the area shaded is the same, right? If you compare both of them, the area shaded on the left square, which is this, and the area shaded on the right square are the same, right? And that is why 1 over 4 is equal to 4 over 16. Okay, let's take another example. All right, now we look at rectangles. Okay, so we're going to show that 2 over 3 is same as 6 over 9. Okay, so for the first rectangle at the top, the whole has been divided to 3 equal pieces, and the same rectangle, the same size, here we have divided it to 9 equal pieces, and we said that we want to show that 2 over 3 is same as 6 over 9. Okay, so for the rectangle at the top, we'll shade two pieces, 1 and 2. Okay, so that represents 2 over 3. For the rectangle below, we'll shade, since the numerator is 6, we'll shade 6 pieces. It's 2, 3, 4, 5, and 6. All right, so we can see that the area shaded is the same, right? They end at about the same mark, right? So 2 over 3 represented by this shaded area is same as 6 over 9 represented by the shaded area for the rectangle below. It would be difficult to each time draw shapes to find out whether one fraction is equal to another. So there's a faster way to do it, right? If we look at 2 over 3 and 6 over 9, let me just put 6 over 9 here, right? There's a correlation between the two fractions, okay? So if you look at it, 6 divided by 2, you will get 3. And same thing for the denominator, 9 divided by 3, you will get 3. So they will have the same value, equivalent fractions. When you divide the numerator, the larger numerator with the smaller numerator, you get 3. And the larger denominator divided by the smaller denominator, you will also get 3. So they'll end up with the same value. When this happens, when you do this division and you end up with the same value, that means both fractions are equal. Okay, they have the same value. Let's go back and look at the other example that we did earlier. We got 1 over 4 and 4 over 16. We take the larger numerator, 4, divide by 1, you will get 4. And you take the larger denominator, divide by the smaller denominator, 16 divided by 4, you'll get 4 also. So you can see that the numbers are the same. So when this happens, that means they are equal. 1 over 4 is equal to 4 over 16. Another way to look at it is you multiply. Okay, so 1 times 4, you get 4. And 4 times or multiply by 4, you get 16. Okay, so same thing with the other example. 2 over 3 and 6 over 9. Okay, this one used the smaller numerator, multiply by 3, you get 6, and the smaller denominator you multiply by 3, you get 9, right? So you multiply by the same number, you create an equivalent fraction. That's the lesson for today. Here are the answers for the worksheet for my first lesson. Okay, these are the answers for question 1 and 2. The answer for question 3. Question 4. Question 5 and 6. Question 7. And the last one answers for question 8. Okay, let's look at some sample problems on equivalent fractions. Okay, state if the equations below are true or false. Okay, if the question does not ask you to show it graphically or draw a diagram, you can just use the tip I gave you just now, right? So, so you divide the numerators, the two numerators, and then you divide the two denominators, and you must end up with the same number. If you end up with the same number, then the two fractions are equal. Okay, let's do the first one, which is this one. So 6 divided by 2, you get 3. 20 divided by 5, you get 4. You can see that you end up with different numbers, 3 and 4. That means 2 over 5 is not equal to 6 over 20. So the answer to this is false. Okay, let's look at the equation below. You take the larger numerator, divide by the smaller one. 9 divided by 3, you get 3. And 21 divided by 7, you also get 3. So you can see that you end up with the same number. That means both these fractions are equal. So it's true. Okay, another problem. Okay, graphically show why 4 over 10 is equal to 2 over 5. Okay, as mentioned in my first lesson, it's always easy to show fractions using rectangle. Okay, so we'll draw a rectangle, but it's good to plan it first. All right, so what I normally do is I look at the denominator. Okay, I will draw the one with the larger denominator first, because when you do that, you'll be able to draw this easily. Okay, so to plan it first. So 10 pieces. Okay, so what I'm going to do is I'm going to plan it 10 pieces. So each piece I want to make it to have a width of 2 squares. So I start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, right, and then the width I want to make it slightly smaller. Let's say up to here. Okay, now I can draw my rectangle. Right, since I got the points marked, I start here and I end it here. Alright, okay, right, I can do another one just above it from here to here. Okay, I got 2 rectangles of the same size. So I'm going to do 4 over 10 first. So I'm going to divide these two 10 equal pieces. Okay, the first one. Second. And 9 and 10. Okay. All right, and then for the rectangle below, 2 over 5. right? I should divide it to 5 equal pieces, and each piece will have, since there are 20 squares here, and I want to divide them to 5 equal pieces, that means each piece will consist of 4 squares, right? So 1, 2, 3, 4. I'll draw a line here. Okay. All right. So this is 2 over 5. Right, now we're going to shade it. So for the first one, we've divided it 10 equal pieces based on the denominator, and then the focus or the shaded area is going to be 4. So 1, 2, 3, and 4, right? And then for the fraction below, 2 over 5, we have 5 equal pieces. And the focus, the shaded area is going to be 2. So I'm going to shade 2 pieces, 1 and 2, right? So we have shown that 4 over 10, represented by this shaded area, is same as 2 over 5, which is represented by this shaded area. As you can see, they end up at about the same mark, right? So this is how we graphically show 4 over 10 is equal to 2 over 5. Okay, problem number 3. Fill the boxes with the correct numerator or denominator values. Okay, so we don't have to draw shapes to find out, to get the answer, right? We use what we have learned just now. Okay, so 7 and 21. How do you get 21 from 7, right? So you multiply with 3. You get 21. So for equal fractions, you have to multiply the same number for the top and the bottom. So for the number at the top, we also have to multiply it by 3. So 1 multiplied by 3. Okay, so the answer is 3. All right, we can check it, right? So we say that when you divide the larger numerator with the smaller, okay, and the larger denominator with the smaller denominator, you must end up with the same value. Let's do that to check. 3 divided by 1, you get 3. 21 divided by 7, you also get 3. So we know that this answer 3 here is correct because you end up with the same number. All right, let's do B. Okay, so same thing. Okay, we divide 9 divided by 3, you get 3. So what number divided by 8, you will get 3. So the answer is 3 times 8, 24, right? Because 24 divided by 8, you get 3. 9 divided by 3, you get 3. So this answer 24 must be correct because only then you get an equivalent fractions, right? Because you're 24 divided by 8, you get 3. 9 divided by 3, you get 3. Since you end up with the same number, then these two fractions must be equal. That means your answer 24 must be correct, right? We can check it. Okay, 3, 9, you times with 3, you get 9, and 8, you times with 3, you get 24. So when we multiply it by the same number, okay, you get the equivalent fraction. All right, let's move on to problem number 4. Write 5 fractions that are equivalent to 1 over 6. Right, okay, so this is quite easy. So we have 1 over 6, right? we just have to create 5 other equivalent or 5 other fractions that are equal to 1 over 6. Okay, so you just multiply the numerator and denominator with different set of equal values. For example, I'm going to multiply the first one with 2. 1 times 2, you get 2. And at the bottom, you multiply it with 2 also. You get 6 times 6 multiplied by 2, you get 12, right? So this is 2 over 12 is equivalent to 1 over 6. All right, so you do another one. 1 over 6, now multiply it with 3, both the numerator and denominator, right? So 1 times 3, you get 3. 6 times 3, you get 18. So 3 over 18 is another equivalent fraction of 1 over 6. Okay, so similarly, 1 over 6, you multiply it with 4 for the top and bottom. 1 multiplied by 4, you get 4. 6 multiplied by 4, you get 24. So 4 over 24 is another equivalent fraction for 1 over 6. So we have 3 equivalent fractions for 1 over 6. Let's do 2 more. So 1 over 6, now you times multiply by 5. You get 1 multiplied by 5, you get 5. 6 multiplied by 5, you get 30. Okay, so 5 over 30 is another equivalent fraction of 1 over 6. Lastly, you can even do a different number. You can do, say, 10. Right? 1 multiplied by 10, you get 10. 6 multiplied by 10, you get 60. Right? It doesn't matter what number you use, as long as you multiply them by the same number. The numerator and the denominator must be multiplied by the same number to create an equivalent fraction. Okay, that's our lesson today on equivalent fractions. I've got a worksheet here, worksheet number 2, for you to try out the problems, and I'll display the answers in my next lesson, which is lesson number 3. Teachers and parents, feel free to share this worksheet with your students or children, and so that they get practice. Okay, we can only excel in maths when we do a lot of problems, a lot of worksheets. Okay, so here is question number 1. This is question number 2 and number 3. Question number 4. And finally, question number 5. All right, that's the lesson for today on equivalent fractions. Hope all of you enjoyed the lesson. Don't forget to try out the questions. And I guess that's it. Okay, see you guys in my next video. Until then, take care. Bye.